First, welcome to the Introduction to Sports Analytics. This is a 15-module course that covers introductory to advanced topics in sports analytics. By the end of the course, you'll have an excellent grounding in the fundamentals of sports analytics. My name is Steve, and I'll be your instructor for the course. I'm an expert in data, AI, and sports, and have 20-plus years of experience. My goal in this course is to pack that 20 years into a few hours of course time. Note that for our online courses, while I create the content and hands-on demos, I work with a professional voiceover team when we produce and publish to the web. You may also see different learning avatars along the way. They'll provide different tips and tricks, best practices, and additional resources for you to use. Jake is our sports scientist, Amy is our data analyst, and Megan is our data scientist. There are 3 learning objectives for this module. Be able to define and provide examples for sports analytics. Understand the history, role, and importance of analytics in modern sports. Identify the components of Alamar's sports analytics framework. This module will break out into 3 themes. What is sports analytics and why it matters? History and evolution of sports analytics. Practical applications of sports analytics. For this first module, the pre-read is the book entitled Sports Analytics, A Guide for Coaches, Managers, and Other Decision Makers. The author is Benjamin Alamar. You should read Chapter 1, which is entitled Introduction to Sports Analytics. I like this book in that it provides you with some fundamental grounding on sports analytics. You'll get a lot of the basics from it. However, it doesn't get into all of the details that you need to know when entering the world of sports analytics. So for each module, you'll have additional reading, references, and case studies that you can use to prep for the course. Sports analytics is the science and practice of collecting and analyzing data to gain insights and make informed decisions about sports performance, team strategy, and even fan engagement. In short, it's about transforming data into insights that power planning, strategies, decisions, and engagement. Simply put, it's about translating data and analytics into decisions and action. Sports analytics impacts areas like team and player performance, strategy, game time events, and fan engagement. For example, sports analytics is used to measure the individual player or team's performance on the field, court, or ice. Discrete statistics and metrics ladder up into views that help coaches, managers, and decision makers. Likewise, sports analytics helps with decisions on coaching, coordinating lineups, and optimizing playing time for different players and lineups. In-game events provide real-time views of a game, so decisions can be made in the moment. And data is increasingly in the hands of fans, as they're more integrated into the game, brands, and lifestyles around sports and athletes. In sports today, analytics are everywhere. For example, the NBA tracks player motion to understand fatigue and improve defensive strategies. And the English Premier League utilized GPS and biometric data to manage player load and prevent injuries. Within fantasy sports, millions of fans are acting like data analysts themselves, drafting teams based on predictive models and player stats. Media and broadcasting companies also leverage sports analytics to create more dynamic and engaging content. Analytics are used to showcase player stats, create real-time graphics, and drive deeper engagement during games. And finally, analytics enhances fan engagement directly. Teams use data to understand fan behavior, offering personalized experiences, whether it's through targeted promotions or app-based game predictions. Sports analytics matters because it bridges the gap between data and intuition, turning numbers into powerful tools that enhance the game for everyone involved, from players to coaches to fans like you. Historically, sports were driven by intuition, experience, and on-the-ground scouting. In fact, there were coaches that were hesitant and even suspicious of integrating analytics into their way of coaching and managing the team. This has changed significantly. Today, analytics has transformed nearly every aspect of the sports world, from understanding player performance and predicting game outcomes to optimizing fan engagement and managing team operations and finances. Analytics is now the core of decision-making, so sports are more data-driven and strategic than ever before. Sports franchises are also operating more like well-run businesses, so analytics are an increasingly important part of the day-to-day business. The impact of sports analytics doesn't stop with professional sports teams. Analytics has spread across a variety of industries, from media companies enhancing viewer experiences, to fitness technology making workouts smarter, to fantasy sports platforms where millions of fans act as data-driven managers. The reach of sports analytics is broader than you might expect. The great thing about learning sports analytics is that once you understand how to source, collect, and translate data into useful insights, this process can be cross-applied to a broader array of career opportunities. Here are 5 steps in the evolution of sports analytics. 1. The early statistical record-keeping era. In the early 20th century, sports statistics were simple, focusing on basic stats like goals, points, and wins. The purpose was largely record-keeping and to report on players and games. This foundational data collection set the stage for future, more advanced analyses. 2. The rise of sabermetrics in baseball, 1970s to the 1980s. Bill James and the sabermetrics movement revolutionized baseball by introducing advanced metrics beyond traditional stats like batting average and ERA. Sabermetrics analyzed player performance more holistically, focusing on statistics like on-base percentage, OBP, and slugging percentage, SLG. This approach, popularized by the Oakland A's in the early 2000s as chronicled in Moneyball, proved that data-driven insights could lead to competitive advantages, especially for smaller market teams. 3. Player tracking and biometric data, the 2000s. Advances in technology enabled the tracking of player movement and biometric data through wearable devices, GPS, and motion tracking cameras. The NBA's installation of player tracking cameras in 2013 allowed teams to monitor real-time data on player speed, positioning, and fatigue. In soccer and hockey, wearable tech gave teams insights into players' physical metrics, which could be used to optimize performance, prevent injuries, and manage load. 4. The development of advanced metrics across sports, the 2010s. As analytics spread beyond baseball, advanced metrics became staples in other sports, tailored to the specific needs of each game. Basketball developed metrics like PER, player efficiency rating, and effective field goal percentage, EFG%, while hockey analytics introduced Corsi and Fenwick metrics for puck possession. Soccer embraced metrics like expected goals, XG, and expected assists, XA. These advanced metrics provided deeper insights, helping teams make strategic adjustments based on quantitative measures. 5. Integration of AI, machine learning, and predictive analytics, the 2020s. Recent advances in AI and machine learning have transformed predictive analytics in sports, with algorithms now analyzing vast amounts of data for real-time decision-making. Teams use machine learning to forecast player performance, assess injury risks, and even predict in-game strategies of opponents. AI has also enhanced fan engagement, with predictive insights powering everything from real-time betting to fantasy sports. This latest evolution emphasizes the importance of data science and AI in modern sports strategy and operations. Each sport has its own maturity model when it comes to sports analytics. For example, the NHL has 108 years of hockey history, and here you can see how analytics in this sport have matured. In the early days, there were simple stats such as wins, losses, goals, and penalties. These early days gave way to advanced metrics and GPS-based wearables, which pushed data management to improve as well. However, as time wore on, more complex, calculated, and derived statistics began to emerge, to the point where today we have AI and machine learning analyzing data collected in real time. In the NBA, player tracking cameras capture real-time movement, allowing analysts to examine positioning, ball handling, and shot selection. For example, teams analyze shot efficiency across the court using heat maps, showing players' success rates in various zones. This shift, popularized by teams like the Golden State Warriors, has led to a focus on three-pointers and fewer mid-range shots, maximizing points per possession and fundamentally changing NBA strategy. Advanced metrics like Corsi and Fenwick track shot attempts for and against a player on the ice, measuring puck possession and team control. Many NHL teams use these metrics to measure and build a sustained offensive pressure, helping them dominate opponents. In hockey, possession often leads to more scoring opportunities, making these metrics essential for successful strategies. Expected goals, or XG, is a metric that evaluates shot quality based on factors like angle and distance from goal. Clubs like Liverpool FC rely on XG to guide players toward higher percentage shots, contributing to their recent Premier League success. XG allows coaches to analyze scoring opportunities objectively, offering insights that go beyond the final score to reveal the quality of a team's chances. In sports, the data collected depends on what needs to be analyzed, whether it's player performance, game strategy, or fan engagement. Let's explore 3 examples of the data types used in sports analytics and how they help teams and organizations make data-informed decisions. First, we have performance data. This data focuses on individual athlete metrics. Think player stats like points, goals, and assists, as well as biometrics such as heart rate, speed, and stamina. For example, a coach might use performance data to evaluate a player's conditioning and track their improvement over time, honing their strengths and addressing areas for growth. Next is event data. This includes every action in the game: shots attempted, fouls, assists, and more. In basketball, event data helps coaches review every play, understanding the details of each event and analyzing patterns that could inform future strategies. And then there's tracking data. This real-time data captures player and ball movements, often collected through wearable tech and tracking cameras. It provides insights into player positions, movements, and spacing. Tracking data enables coaches to analyze player positioning and adjust tactics accordingly. Heat maps, for example, can reveal how much time players spend in key areas of the court or field. In his book, Sports Analytics, Alamar outlines a simple sports analytics framework, which is made up of 4 key components. 1. Data management. 2. Analytic models. 3. Information systems. And 4. Decision maker. This framework helps describe how different components of the sports analytics process come together to help inform the decision-making process. Data management is the foundation of Alamar's framework and involves all aspects of collecting, storing, and organizing data in a way that ensures its quality, reliability, and accessibility. And there's a lot that goes into data management. Effective data management involves identifying relevant data sources, ensuring accuracy, and minimizing biases in the data. Without effective data management, any analytic insights are likely to be unreliable or misleading. Analytic models are the core of the framework and involve applying statistical and mathematical techniques to extract insights and patterns from the data. Typically, you have descriptive, predictive, and prescriptive analytics. It's also common to start analytics projects with an exploratory analysis, which can include summary statistics, descriptive analytics, and perhaps some advanced analytics, for example, correlation analysis. A descriptive analysis looks at historical data to understand past performance, trends, and patterns. Predictive models use historical data to make predictions about future outcomes, and prescriptive models provide recommendations for action. Analytic models are used to convert raw data into actionable insights. By applying various levels of analytics, sports organizations can better understand their players, make informed predictions, and optimize their strategies and decisions. Advanced analytic models, including machine learning algorithms, are often employed to handle complex data sets and uncover deeper insights. For instance, tracking data from wearable technology and advanced player metrics may require machine learning models to recognize patterns that are not immediately apparent. Information systems are a bit boring to talk about, but they are the tools, platforms, and applications that deliver analytic insights to decision makers in a user-friendly format, enabling them to take action based on the data. This might be dashboards and visualization tools, reporting systems, mobile applications, and so on. Information systems bridge the gap between data and decision-making. They make data-driven insights accessible and understandable to non-technical stakeholders, ensuring that data can effectively inform and support decisions at all levels of an organization. Ultimately, all of the above need to come together to support data-driven decision-making within sports organizations. When properly integrated, data management, analytic models, and information systems create a streamlined flow from raw data to actionable insights. Sports analytics offer powerful insights, but its implementation isn't without challenges. These challenges impact data accuracy, usability, and raise important ethical considerations. Let's break down some of the key challenges that sports organizations face. Data quality and accuracy. High-quality data is critical for analysis, but inconsistencies or even errors in data entry can lead to inaccuracies. This affects downstream analysis, potentially leading to misguided decisions. For example, if tracking data inaccurately reports player speed or positioning, coaches might make strategy adjustments based on flawed information. Interpreting complex data. Sports data is often multidimensional, making it challenging to interpret. Miscommunication between analysts and decision-makers can lead to misunderstandings, and insights can be lost if they aren't conveyed effectively. Advanced metrics like expected goals, XG, require context to be useful. Without it, coaches might make decisions based on a skewed understanding of the data. Real-time data processing and usage. Real-time data is a huge asset during games, but processing it quickly enough to make in-game adjustments can be technically demanding. Delays in analysis can mean that crucial insights are missed. For instance, if positioning data on opponents isn't processed fast enough, teams might miss chances to adapt tactics in real time. Privacy and ethical concerns. Collecting data on athletes, especially biometric data, raises concerns around privacy and consent. Ethical missteps in handling this data can harm trust between players and organizations. For example, if sensitive data from wearables, such as heart rate or stress levels, are mishandled, it could affect player trust or even influence contract negotiations. Data integration and compatibility. Teams often use data from various sources, tracking systems, wearable devices, and performance metrics, which may not always integrate smoothly. This can make it difficult to create a complete view of player performance. For example, if data from wearable tech doesn't align with video analysis tools, combining physical and tactical insights becomes challenging. Resistance to data-driven decisions. In some environments, there's resistance to analytics, with coaches or executives relying more on experience than on data. This limits the potential impact of analytics. For example, a coach who values intuition over data might overlook analytics-backed suggestions, such as optimal lineups or timing for substitutions. Rapidly evolving technology. With technology constantly advancing, sports teams need to stay up to date with the latest tools, which can be costly. Teams unable to keep pace may find their analytics programs outdated, impacting their competitive edge. Without the latest tracking technology, for example, teams miss out on detailed data that rivals may use to improve strategy. Resource and budget constraints. Implementing advanced analytics programs requires substantial investment in technology, personnel, and data acquisition. Not all teams can afford this, creating a potential imbalance. Smaller teams in leagues with significant spending disparities may lack the resources to build robust analytics teams, leaving them at a disadvantage. Predictive models and uncertainty. Predictive models are valuable, but sports remain inherently unpredictable. Overconfidence in predictions can lead to incorrect or risky strategies. For example, a predictive model might give a soccer team a high likelihood of winning, encouraging an aggressive game plan. But unexpected events, like a red card, can disrupt predictions, highlighting the need for caution. These challenges underscore the complexity of implementing sports analytics effectively. Addressing these issues requires technical solutions, strong communication, ethical standards, and commitment across all levels of a sports organization. Overcoming these obstacles is key to maximizing the potential of sports analytics and ensuring its positive impact on team performance and player development.
To follow additional resources for you to explore on your own time. The first is a case study from the Real Madrid Football Club in Spain. and the second is a case study from the Buffalo Sabres. Review the case studies and see if you can answer the questions on the next couple of slides.
In this lecture, we introduce you to the topic of sports analytics. You should now understand what sports analytics is, why it's important, and where it can be applied. You should also now understand how sports analytics has evolved from gut feel to real-time data collection from wearables and AI-driven computer vision translating games to distilled statistics for fan engagement. Sports analytics is a fascinating and broad area of study, and in this course, we'll dive into many of the topics you learned about in this initial module and much more.